So this is 12.3, cylinders and cones. That's a cylinder and that's a cone. Okay, so the only new information you're gonna learn is pretty much in here, and then it will make intuitive sense to you. So let's go over this. Okay, so this is some kind of what is it? 1, 2, 3 pentagon, right? Doesn't matter, hexagon, or equilateral triangle, whatever it is. For prism, the lateral area is perimeter times height, right? Perimeter times height. And volume is base area times height. So what do you think the lateral area and volume are for the cylinders? What do you think? Should be quite similar, right? So in fact, it's almost identical. So for the prism, lateral area is perimeter times height, right? For the cylinders, lateral area is, height is the same. What do you think you're going to multiply with? Circumference. Perimeter, circumference. So this is 2 pi r h. That's it. It makes sense, right? And for the volume, prism, volume is base area. So this should be capital. Actually, this should be capital too. Base area times height. So for the cylinder, the volume should be, the height is the same, and it's area of a circle, right? So the area of a circle times height. So that means it's pi r square h. That's it. And for the cone, lateral area is 1/2 of perimeter times height, and the volume is 1/3 of base times height. Okay, so for the prism, no, I'm sorry, this is a pyramid. Pyramid, lateral area is 1/2 of perimeter times height. So for the cone, lateral area is 1/2 of the circumference times height. So that means 1/2 of 2 pi r times height. And 1/2 and 2 cancels, so it's pi r times height is the lateral area. Lateral area, not the total area. Total area is this plus the area of the base, right? And for this, the total area is lateral area plus 2 circles, right? That would be total area. Okay, so that makes sense, right? And for the pyramid, volume is 1/3 of base area times height. And for cone, volume is 1/3 of the area of the base, so that would be area times height. So 1/3 of pi r square h. Oh, sorry, you couldn't see. Okay, that's really the only new concept. The problems can get hard, but that's really the concept. Okay, and then it does make sense. If you understand these, you're just replacing it with a perimeter, with circumference, and area with area. The rest is the same. Okay? All right. So objective is identify the parts of cylinders and cones. Cylinders and cones. And find the lateral area, total area, and the volume of right cylinder and the right cones. Okay, and the idea of the right cone versus the oblique cones are the same. See, so these are the right cylinder, right prism, oblique prism, oblique cylinders. We don't deal with these in this textbook. We just deal with this. Okay. And the terms are the same, the radius, the height, or the altitude. It's really no new terms other than, let's see. The lateral area is 2 pi r h, and the volume is pi r square h for the cylinders. And for the total area is 1/2 of 2 pi r times L, or it's pi r L. L being slant height. Okay, hold on. What did I say on the first page? The lateral area. Okay. All right. Not the height. Sorry. This is the slant height. You remember when you had to do this? This wasn't the height of the pyramid. Sorry, it shouldn't be an H, and this shouldn't be an H either. Actually, this should be L. There's an error here. Okay. This is not the height. This is the L. The height is this, right? This is the H. That's the H. This is L. You remember, to get the area of a triangle, you have to get the height, which is the middle of the isosceles triangle. So this would be L, right? 1/2 of perimeter times the slant height. So for the cone, it's the 1/2 of the circumference times also L, which is this distance right here. Okay. And this is L. This is L. And these are all, no, this is height. This is height. For the volume, oh, sorry. So this is H. This is okay to be H. This have to be L. Sorry about that. Okay. And these are height, because the volume you need the height. For the area you need the slant height. Just like for the prism, you needed the L as well, right? So it's pi RL, no pi RH. Okay. And for the volume, it is H. Okay. And this, you know, if you're looking at the prism or the pyramid, this length and this length are different, right? This is longer than this. And this was called the slant lateral edge. This was lateral edge. And this was slant height, right? And this was base edge and so forth. For the cone, these are all the same length. It have to be the same length. So you don't have to distinguish between the lateral edge and the slant height. Okay. All right. So let's look at a couple problems. Okay, I think these are all right. So this just makes sense that the radius is 5 and then area is 25 pi, and times 4 to get the volume, and 10 pi to get the circumference, and you multiply that by so 2 pi times 5 is 10 pi, and the height of 4, and 40 pi is the lateral area. And to get the total area, you just add 25 pi, 2 of those. So add 50 pi, so 40 pi plus 50 pi is 90 pi, and so forth. Just look at this one. Okay. First, you have to find the L. So if this is 3 and this is 6, this have to be the 6 squared plus 3 6 squared is square root of 45, which is 3 root 5. So this is 3 root 5. And so the lateral area is pi times 3 times the 3 this, and you get that. Okay. If you don't want to use a formula, but you want to use from the thinking of the pyramid, the lateral area or pyramid was the perimeter times the slant height, right? And in this case, the perimeter is the diameter times pi. So diameter pi times pi would be 6 pi. And the slant height is 3 root 5. Okay? And then actually, you need to get the 1/2, right? Lateral area was 1/2 of perimeter times so you have to have 1/2, and then this get to 9√5, the same thing. Okay, and so the total area, you just add the 3 is the radius, so the area is 9 pi. So you can combine, you cannot combine them, right? This is like 9x plus 9, so this is how it stays. And the volume is 1/3 of the area times the height, so 1/3 of the 9 pi times the height will give you 18 pi. Okay. Okay, so let's see. Sketch each cylinder, then find the lateral area, total area, and the volume. Radius and high radius and high radius and high radius and high. These are all same. So just do 3 maybe. Okay, you just need to do 1 for these. And then the volume of a cylinder is 64 pi if R equal H. All right, that's a good one. This is homework. This is homework. The volume of a cylinder is 72 pi if H is 8. Find the lateral area. You can do this one. Okay. I don't know. Do we need to do one of these? Maybe we do 5 and then you do 7? Yeah, let's do that. Right. So video. Alright, so let's do this one. The volume of a cylinder is 64 pi. So the volume is 1/3 of base area times height, right? And that's 64 pi. And radius is the same as height. Okay, so 1/3 of the base area is pi r square times height is 64 pi. Okay, and r and h are the same lengths. So this is the same as 1/3 of pi r cube equals 64 pi. Right? Now it's one equation with one variable. You can solve it. You can cancel pi. You can multiply 64 by 3. And this is r cube is 64 times 3. But is that going to be a clean number? Let's just see. 7, 5, yeah, it should be a clean number. 64 is 8 times 8, so that's 2 times 2 times 2 times 2 times 2 times 2. The 3 is going to get left here. Sorry guys, I forgot to read the problem. This was a cylinder, so you don't need a third. That's why I was confused. So you don't need a third. It's the base times height is this. So this is, you don't need a third. I was thinking, why is the 3 is left? All right. So the r square is 64. So you can put in a calculator, or if you can use a calculator, because on the SAT, for example, you only get to use the 4-function calculator. You do this is 8 times 8. So this is 2 times 2 times 2 times 2 times 2 times 2, right? And you are taking the cube root because r is cube root of 64, right? So once there is 3 of the same thing, they can come out. You remember when the square root you have 2, then you can come out. Now if it's cube root, you need 3 of them to come out. So 2 2's come out, which is 4. Okay, so r equal 4. All right, you do 7. And this one is a good exercise. You have radius, the height, and so on height, and then you have to get the lateral and total and volume. I don't think you need to do this because these are simple. I want you to practice with, it's good to do these. Why don't you do all of this? Okay, especially these one that you have to go from the volume backwards with radius or the lateral area backwards. Yeah, I think maybe you do just 11 and then these 4. Okay, these are good practice. And I think the rest we can do in the class. Okay, and look at here. These are the problem I was talking about. The things that goes in a cylinder and so forth. Okay? Good.